Welcome back to our channel. Today, we're diving into one of the most fascinating and powerful tools in data analysis and machine learning: curve fitting and regression. Imagine being able to predict the future, estimate unknown values, and uncover hidden patterns in your data, all with the magic of mathematics and a few lines of code. But what exactly is curve fitting and regression, and why is it so important? Curve fitting is all about finding the best mathematical function that fits a set of data points. Whether you're working with a simple linear relationship or a complex nonlinear pattern, curve fitting helps you model the underlying trend. Regression, on the other hand, is a broader concept that involves predicting one variable based on the value of another. Both techniques are fundamental in fields ranging from economics and engineering to biology and social sciences. Let's start with a simple example to illustrate the power of these techniques. Suppose you have a data set of the average daily temperatures and ice cream sales for a month. By using linear regression, you can find the relationship between temperature and sales, allowing you to predict future ice cream sales based on the forecasted temperature. But it doesn't stop there. Curve fitting and regression can also handle more complex scenarios. Think about predicting the growth of a pandemic. By fitting a nonlinear curve to infection data, public health officials can estimate future cases and implement timely interventions. This capability is crucial in saving lives and managing resources effectively. In today's video, we'll walk you through the basics of curve fitting and regression, show you how to implement these techniques using MATLAB, and explore some real-world examples that highlight their incredible potential. By the end of this tutorial, you'll be equipped with the skills to make accurate predictions and insightful estimations from your data. So, grab your favorite beverage, get comfortable, and let's dive into the world of curve fitting and regression. In today's video, we're going to apply the concepts of curve fitting and regression that we introduced earlier. We're going to dive into a practical problem that will help solidify our understanding of these powerful techniques. Here's our problem. We have 3 data points. Our goal is to find polynomial equations that pass exactly through these points. Specifically, we will first tackle fitting a quadratic polynomial and then a cubic polynomial to the data. Why is this important? As we discussed earlier, curve fitting allows us to model data points with a mathematical function. By finding the best fitting curve, we can make predictions and understand relationships between variables. In this case, we'll use quadratic and cubic polynomials to see how well different types of curves can fit our given data. What we'll do? We'll start with a quadratic polynomial of the form. This will help us understand how a simple curve can approximate our data. Next, we'll move on to a cubic polynomial of the form. This will show us how a more complex curve can fit the data points more accurately. By the end of this tutorial, you'll see how to use MATLAB to compute the coefficients for these polynomials, giving you the exact equations that pass through our data points. Ready to dive in? Let's get started. Now, let's tackle part A. We'll find the coefficients of the quadratic polynomial. We begin by defining the given points. Next, we'll extract the x and y values from these points. Extracts the first column, x values, from the points matrix. Extracts the second column, y values, from the points matrix. We need to formulate the matrix A and vector for the system XB. For a quadratic polynomial, we can now solve for the coefficients using the least squares method, which is done by the backslash operator in MATLAB. Display the coefficients. Displays a message indicating the coefficients of the quadratic polynomial. Displays the coefficient displays the coefficient b. displays the coefficient C. Great! We've successfully found the coefficients for the quadratic polynomial. Now, let's move on to part B and find the coefficients for the cubic polynomial. We'll start by using the same points as in part A. Again, creates a matrix with the given points. Extracts the first column, x values, from the points matrix. Extracts the second column, y values, from the points matrix. Formulating the matrix A and vector B for the system X, B. We'll solve for the coefficients using the least squares method. Let's display the coefficients. Displays a message indicating the coefficients of the cubic polynomial. Displays the coefficient A. Displays the coefficient B. Displays the coefficient C. And there you have it. And that wraps up our exploration of curve fitting and regression. We've just seen how to fit both quadratic and cubic polynomials to a set of data points, and how to determine the exact equations that best represent those points. By using MATLAB, we were able to find the coefficients for these polynomials, and with those coefficients, we can predict future values or understand the relationship between our variables more clearly. This practical application of curve fitting helps demonstrate its power in real-world scenarios. Finally, we have the coefficient values filling the quadratic equation and the cubic polynomial. The independent variable x behaves like the temperature in the ice cream. Problem as discussed earlier, and y is the ice cream sales that depend on the temperature. Therefore, now both these equations can help to predict the value of e for any arbitrary value of x. In the next tutorial, we will see which polynomial is better to predict a given case study. There are a few parameters that tell us about the accuracy of the modeled equation. If you enjoyed this video and found it helpful, remember to like, comment, and share. Thanks for watching.